I think we're going to start by going through the absolute basics and seeing what you know, and we'll just skip through until we find where you are. There's also like branches of things. You don't learn things in a linear fashion. You've got to learn one field that may help in another field, but they may be completely unrelated, and you may not need one for another kind of thing.
Okay.
But we're going to start with data types, as that's the first thing you place down is data types, and then you work with those data types and form them into certain you form them with certain functions into a result that suits your need. So data types specifically I'm talking about are all of these input nodes, and I'll assume that you are familiar with some of the terms here.
Some of them. Int, I know, is an integer, and Boolean is what, like a yes or no or true false, actually.
Yeah.
Impulse is to fire it, to make it happen, right?
Yeah.
String is a value that is letters, not numbers.
Yeah.
And
well, specifically, a string is an array of characters.
Okay, good, better. Because numbers can be part of a string.
Exactly.
Okay.
It's basically just the character form of things. You can. Do you know what parsing is?
I've heard of that, but I do not know what it is.
So parsing, P-A-R-S-E, to parse something means to, in this case, for a string, to parse a string, you can tell the system, hey, I want this string in a number. So if you put 15.2 in the string, you can parse it to a float, and it will give you 15.2 as a number to work with as a numeric function, in a numeric function.
But you couldn't parse a series of letters to a number.
No, that would fail. And it would just tell you that it failed. But the float is like an int, but it has decimals. And we also already spoke about character. So this only contains one character. So you can think of a string being a bunch of these little bits put together. And when we talk about impulses, this is not something native to programming. We don't have these in like any programming language. I mean, you may in some, but I don't know of any. These are just a way that we are visualizing the flow of method calls. So in programming, you would have, say, a method which is used to add two numbers. So add A, B. And you would have another method that says, I want to call the add function on 1 and 3. And then this add function would do that somewhere. So that's what this is representing, is that method being called. This goes into something. In this case, it goes into a display function. So when you pulse this, it sends a signal to this, which causes it to display something.
Okay.
And that same thing is actually happening under the hood for everything. So if we have a display, I can just drag it out. If we have a display right here, this node is actually propagating backwards. It's saying, okay, what's on the end of my line? What do you have to give me? Because this has some output. This is an output that this function is giving. So basically, when it's just a value like this, we can think of it like it's just a raw value that it's providing to whatever needs it. But it's not giving them the value. It's actually being requested by this. But we'll get into that a bit later on, because that's very specific to LogiX. When we're talking about programming, we probably want to go a bit more front to back rather than back to front like LogiX does. LogiX is a bit different in that sense, but do you know the difference between operators and all the other groups?
The ones that I know, well, I don't know the difference between string in here and string in the last one we just talked about, but I don't know much about these.
A string is basically just all the functions that a string has. But a string, you can try to substring at a specific location. So if I have some text, then substring means to cut that string somewhere. So I want to cut this string. Right now it's cutting it from 0, which means it's just the same string. Cut it from 4, and now I have
okay, so 4
that
characters
goes,
in.
yeah, so it goes 1, 2, 3, 4, cuts that away.
Okay.
You can also set how much it cuts out. So I want to cut out 1, it just takes the U.
Interesting.
So that's basically what the groups mean. It's just relating to a specific data type in that sense. And remember, data types are basically all the different types of values, which is another thing. There are different kinds of data types. These are value data types, and we have two main ones that you're going to encounter in Neos: values and objects. Objects use references, so a slot is a object data type, and it can be null. Basically, all well, without getting too complex, just think of it that a value data type can not be null. It is always some value.
It's always
Even if
0
that
or
value
something.
is, it's either 0, it could be not a number, it could be infinity, but it's never null. It is always equal to something.
Okay.
But objects have the ability to be null. They can just be equal to nothing. They have no reference to anything. And that's not always the case, because there are some cases like instructs, but we won't get into that because you're probably not going to be applying this to generic programming at first. You're probably going to be doing LogiX with all this.
Okay.
But we do want to be thinking about how things are interacting.
Now, I hear
Are
the
you
word
following along?
slots a lot. A
Yeah.
lot of people talk about slots, and what it sounds like to me most of the time is that it's these I guess sections of the world where individual things go into that, almost like little.
Okay.
I mean, I guess, yeah.
So if you think about a slot, here's my slot. It's an object, or represented with a square. So a slot is basically an object, and objects can have other objects. Actually, let's think of this more like a box, right? So we've got our box here, and our box can have other boxes inside of it that all contain their own boxes as well. And maybe this is in a big box also. So basically, slots are just things that are able to be like a child of or a parent of. Are you familiar with those terms?
Okay. Yes. Yes. It'd be like
And
subfolders and
right.
yeah.
So the same way you can have a folder hierarchy in Windows or anything like that. Now, if we have a slot, then this slot can also have functionality. As you know, we have like the IK systems, and those are on slots. Now, when I say they have like a functionality, this is what we put components there for. Components are what provide a slot with its functionality. So a component has to be on a slot, but a slot does not need components.
Okay.
Usually it will have something, other than cases where it's just used for organization. The only exposed fields of a slot that you can't get rid of are the position, rotation, scale, and things like that. Because
Because
it needs to know
it
that.
needs some sort of physical property, essentially.
Right. It needs to know where it's operating. Otherwise, I mean, it doesn't necessarily need it. You could just have a list of slots that have a hierarchy, but then if you added the component, it wouldn't be able to function because, well, it doesn't know where it is. I mean, some components would be able to function because maybe they would hard code global space values, but it's just convenient. It's
Gotcha.
convenient to have those fields have to be there.
Okay.
And so if we sort of think about those components, you've got your transform, which is, it's sort of locked there, right? That's not a padlock. Yeah, it's sort of locked there. You can't get rid of the transform. But you can have other components which are not locked there. You could have the dynamic bones. And dynamic bones, they provide their own functionality by searching for all of the child slots, and then they go down that chain, and they link and apply physical properties in a propagating manner, and that's just functionality that's applied to this slot and its children. So that's what components are. They basically are compressed logics. LogiX runs a bunch of functions the same way that components do. And that actually gets into the point that LogiX is just components on slots. So when you build LogiX, you're just building a series of components that talk to each other. That's how it builds the functionality.
Okay, that makes sense. And then they all rely on each other and are stacked, basically.
Yeah.
Okay.
Now, without what are called conditional statements, you wouldn't have programming. Conditions are the fundamental process, the fundamental, important thing within programming that makes programming not just a mathematical function. Now, when I say conditionals, I'm talking about this. Take two values, true or false, give me the value representing that true or false value. You've used this before?
No.
Okay. So here, we'll do it with this. Actually, you know what? I changed my mind. We'll do it with a float. So basically how this works, this is called, well, in programming, this is called a ternary operator. And a ternary is just, it takes two values and it will give you one or the other dependent on true or false. So if we have 1 in false, then it gives us 1. If we switch it to true, it gives us 0, because this is our true, this is our false.
Okay. So the inputs, whatever the inputs end up being, whether it's 1, 0, or banana or an apple, if
you could put anything in there.
And true is always the top, false is always the bottom blue, the one in the middle.
Yeah.
Okay.
So this is still just a mathematical function, because if you break this down, if you were to compile this, and compilation is the process of taking some functionality and taking it down to its raw components, what it would end up doing is saying, okay, well, I mean, this is always true, so I'm just going to pack it as though it's just 0. This entire function just equals 0 because this is a static value, this is a static value, and things like that. It doesn't matter. So it will just give you 0 every time. So we need something to control this. And what we can use is maybe we have to check if time has passed a certain amount. So we'll have an elapsed time, and the elapsed time node just tells you how much time has passed since it's been impulsed. So I press the pulse and it starts the timer over again. So we want to check, okay, maybe after 5 seconds, I want this to be true. Well, to do that, we need to use what's called a greater than condition, right? And greater than, I'm sure you've seen this in math, basically just this. And in programming, this says, is the top value bigger than the bottom value, right?
Mm-hmm.
So logically, we take the time and check, is it?
Sorry,
Okay.
Yep, good.
We can check if this is bigger than 5, and this is in seconds. So then we pulse this, and it'll be false until this reaches 5.
Oh, cool. Nice.
So now we can take this expression and plug it into this ternary operator. And now pulse it again, it'll be 1. And after 5 seconds, this will turn to 0. And that is the basis of programming. If we didn't have conditions, and if we didn't have ternaries, and if we didn't have dynamic inputs, we wouldn't have logical processes.
Okay. Yeah, so that really simplifies it. All right, so based on that, you've got 0 is input true, 1 is input false, And these right here determine whether or not the value that comes out of the final result is true or false.
Right.
When it's true, it
Exactly.
says 0. When it's false, it says 1.
Yep.
Okay.
So as long as you can understand that, all we need to do is teach you all the different operators and, well, not all of them, but I'll give you a clue as to what they mean and how you can figure them out for yourself, as well as what I think is the most practical way to do this is build really small things. Like you can literally make a button that when you press it, it stops you from being able to press it again until a certain amount of time has passed.
Huh.
Something like that.
Right.
Or maybe a button that you press that then maybe it's a lever and something pushes the lever back and it's just a useless lever sort of thing.
But it's training. It's like the fundamentals.
Right, and it's a
Yeah.
fun toy as well. I would like to see a useless lever.
You can play with it all day.
What's it called? A useless switch? I always forget.
And
Useless machine?
what was this called again?
A ternary operator.
Ternary operator. Okay.
Yeah. In probable primes tutorials, which if you're going to be learning LogiX from scratch, I would highly recommend you watch those. He calls them the question mark colon node, which he only says that because people won't understand ternary.
Okay.
So when he says question mark colon, he's talking about this.
Gotcha.
It's also known as the if-else statement because it's checking. In programming, this would be written like I want my my variable meaning my I mean, you know what a variable is in math. It's like you could have x. If you're doing algebra, you have x, and this is my variable, and it's x is equal to 1. So variable x is equal to value 1.
It's a representative character.
Right. So in our case, variable x, we could say that equals, and this is where the ternary is used in programming. If true, we'll say we'll just say my Boolean being that true or false. So this could be true or false. We don't know. And we'll say my bool, if that is true, question mark, then use value 2. And if it's false, else, use value 7 or something.
Okay.
So that's how you'd write it in programming. And that's why it's depicted with a question mark and a colon. This is the same as saying, if my bool is true, set value x to 2. Otherwise, set it to 7.
Okay. Gotcha.
Are you following along?
Yes. If, all right, variable x is, okay, let's try this again. Variable x equals true 2, else
Yeah.
7.
Right, exactly.
Okay.
And have you heard the term like if else before?
Yes. Like if then else, that just barely way back in school when I took basic, visual basic. Yeah.
Okay, cool. That's helpful then. I mean, if you check that, that's going to simplify things. So now we have, you know about the greater than. You obviously also have the less than, which is the opposite. And then you have these ones which have a little line under them. Do you know what they are?
Greater than or equal to.
Exactly. So we also have those ones, and those are specifically working with numbers, but you don't always work with numbers. You could be working with purely Booleans, just true or false. I want to check maybe is something within a range of 0 to 5. And so to do that, I would say is I'm going to use a relay here, just because it makes it a bit easier to replace this later on. So if this value here is greater than 0, then that's going to tell me true or false. But let's say I have 9. This isn't telling me if it's also less than 5. So we'll also want a less than. Is my value less than 5? And this tells us it's false. So with these values on this side, we want to know if any of them is false, then return false. If both of them is true, then return true. And a way that this is commonly written is like this. We have a graph, which is showing you all the various states and their results. So it has 3 columns and a series of rows where you have so v1, v2, and result. So we have maybe true, true, and this is going to result in true. If we have false, true, we have false. If we have true, false, we have false. And if we have false, false, we have false. So it's always false unless both of them is true. Do you know what that is called?
No, I don't know what that's called.
That's called an AND operator or an AND statement. So AND checks is both of them true. So if this and this, so you can see it's returning false.
Oh, okay.
So
and
this
if we
is just
plugged,
one of many.
Gotcha. So if we plugged 15 into the bottom, then it would be true, true.
Yep.
True. And that would, oh, gotcha. Okay.
And then if we went maybe negative out of the bounds, and it's false.
Ah. Now, what? Just for purposes, because we just used it, what exactly is a relay?
A relay is just a way to reroute the wires. It's purely organization.
Okay.
Which that's actually getting changed in soon enough. I'm actually working on an update to make these a lot cleaner. They look something a bit more like these now. Let me just get rid of these. So this is what relays are going to look like in a newer version.
Okay. And you use it to separate, or to essentially, from what I can tell, that relay let it separate it, right?
No. You can just plug both in like this.
Okay.
The only reason I did it like this is because we can now put a different value in, like time, into here, and it automatically routes to these two.
Ah, gotcha.
So put in time, and now they're both false because time is way too big.
Ah, so that's the organization level of it. Gotcha. I see.
Right, exactly. Just makes it easier to both teach and to read. So if I press this, now it's going to be true until we surpass 15 seconds. I can't be bothered to wait 15 seconds, so that's 5 false. There we go.
Okay, cool.
We can also check, maybe between 3 and 5, so it has a 2-second gap. So it's false, true, false. Okay, that is one of many, though. So we're now going to go through all the important ones because they don't have obvious symbols in Neos. They use the shorthand expression in C#. So usually in something that was a bit that in other programming language they would literally write and in C# you have the ampersand, and in some programming languages you would have or. No, obviously or just means if one or the other are true, then return true. And in here let's build up the graph again. So we have v1, v2, result, and this is for or. Then we have true, 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 false, false, true, false, false. And do you think you can figure out exactly what the result would be for all of those cases?
Let's say if it's or, then true, true would be false. No, wait. So does or refer to if it's true or false?
Or means if either one of them is true.
Ah, okay.
If
Then it
this one
would
is
be,
true, or if this one is true.
so it'd be the opposite, right? So it would be true, false, true, no, true, 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 false.
Yeah, exactly. So that one is it's basically as common as and. Like these two are sort of hand in hand. They're the most common ones I would say in programming. You can actually see a lot more inside of the node menu. So or is not depicted by or. So the reason I wrote this out down here. Or in Neos and in C#, you write a pipe, a vertical line.
Okay.
So that is this. So this is an or statement. Everything that starts with the integers is just because of like binary stuff. You don't need to worry about it too much. We can just plug a Boolean into it. So then this should give us the exact same results. So in case if it's true, true, true. The only case where it's false is when both of them are false. You can add as many inputs as you want and it acts the same way. If any one of these is true, then it will return true.
Okay, nice. So that would be the kind of thing where if you had 5 buttons, and as long as one button was lit, it would pass.
Exactly. So we have a lot more than that, though. As you can see, let me just point out all the ones that have their own properties, the ones that are important. I think that's all of them. All of the ones that are important, at least. Okay, so we'll sort of go in descending order on commonality. I'm just going to put this next to that, as well as this next to that. Okay, so we've already gone through these two, but these ones are even more simple. This just checks is, hold on, let me just get that Boolean. Is one value equal to the other value? So we can just one more time write out a graph just to get this sort of map in your mind. You can do this yourself for any of these. Like you can go through, pick an operator, put in two values and see what it does, write out a map and try to understand it. Okay, so for equals, so that's depicted with two equal signs. The reason it's not depicted with one is because one equal sign means, say x is equal to 5. It is assigning the value of 5 to x. Whereas equals is checking, is this equal to this?
Ah, gotcha.
And that returns a Boolean. So all of these ones that I'm writing a graph for always return true or false.
Okay.
So in this case, for equals,
It would be true, false, false, true.
exactly. And then we have this other one, which means not equal. And you can probably figure out that's just the inverse.
Right. Okay.
So basically, that exclamation mark means not. It is also sort of used for inverse. So if we have a Boolean in this at the top, this means to inverse the input. So false becomes true and true becomes false.
I've also heard bang operator. Is that correct for that?
I've never heard that.
Never heard that. Okay.
I always just know it as the not operator.
Okay.
There's many more than this. I mean, you already know about the other ones. There's many more that are sort of subsections. It's going to be cramped over there. But the other ones are going to be this one. This is an XOR operator. There's also NAND, NOR. These ones you don't really need to know. I rarely use these. The only times that you would use them is to compress your code, because it literally just means not and not or. These are different from doing. Okay, so you know how we have equals and not equals?
Yes.
We have and not and, because as you know, it's on and it's true, false, 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 and on or it's true, 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 false. So they don't line up. It's not an inverted. It is not inverted because it's like offset where it's 3, 1. In terms of if we come over here, like we see it's true, 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 false down here.
Oh. Okay, gotcha.
You see on the or we've got true, 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 false. But we can't just inverse that because that would make false, 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 true. That's not an and operator because an and operator would be true, false, false, false. So it's not a direct inverse. And is not the opposite of or. So what we have is NAND and NOR.
All right, gotcha. I need to spin around here. There you go.
These aren't really important. Like I said, it just helps you compress it because this operator is the same as doing this. So these will result in the same. So if I put true, true, it's false, false. Either one being, if it's true, true, then it just returns false, false. That make sense?
No, okay, let's look at it close here. So we've got true. Basically, if it's not and, so it could be any combination of not and. Any combination at all. As long as it's not that one key, then it says true, because NAND is, so because this is and, that's a correct and, then not and is false.
Exactly.
Okay, but if there were a whole line of trues and one false, then not and would be true.
Exactly.
Okay, gotcha.
All right, so that's pretty much everything you need to know about conditionals and operators. Well, when I say operators, I mean Boolean operators, things that work purely with true or false.
Okay.
Everything else is down to the software or the programming language you're working with. I assume you're going to be mainly focusing on LogiX.
Yes.
So we can then just start talking about LogiX, some very useful things in LogiX, though I don't want to overwhelm you. I know you're recording it though, so